Hello and thank you for contacting Wave. I see from your clinical request your patient is struggling with a little bit of discomfort with the lenses, and you're noting some decentration, notably some dropping of the lenses on the fit. So a couple things we can look at with this design. You have some nice topographies, and your initial choice of doing a G-SIM I think is a right choice based on these corneas being quite symmetrical. Just some general comments: since it's a higher cylinder lens, I generally like to capture as much of this corneal data as I can to get that lens to line up properly. And just a couple thoughts here. When you're looking at this, as you know, this is your flatter meridian, this is your steeper meridian. So these lenses, being a little higher powered, may have the tendency to drop down the steeper slope here. So they're going to have a tendency to rock along this meridian here, maybe dropping and then centering a little lower. So you want to capture as much corneal data as you can. So one thing I like to do if I have pretty nice looking topographies like this, when I first open Wave, I try not to use the averaging of the astigmatism. When you average the astigmatism, I think sometimes you'll hide a little bit of the critical corneal detail, and using as much topographical data as you can will help these lenses center better and not rotate and mislocate. So a couple thoughts. If we look at your design here, I like your initial design of this right eye. If you'll notice, so if you look at this landing area between the blue and the pink dot, if we kind of follow it around, you'll see it's a little bit inconsistent. You'll see it dips down in this 3 o'clock radial, and then it kind of lifts up a little bit on the other end of the 9 o'clock, and so you have a little bit of inconsistency in that critical landing area. And so if we visit the question about tangential versus axial, if you recall, tangential will tend to look more closely at the peripheral topography, and so I find that they give you generally nice alignment in those peripheral areas, while axial probably gives you a little more true representation centrally. But if you look at the difference between the two, axial will tend to be maybe a half diopter steeper or so than the tangential. I'm a big fan of tangential, but you just have to work on getting that alignment nice in that landing zone. So one of the ways you can do this, as I mentioned, the G-SIM was a nice looking initial design, but if I'm struggling with getting the lens to center, I'm going to try to capture as much data as I can. So I'm going to switch over to Freeform, and I did a quick little sample lens here somewhere if I can bring it up. And it looks like I lost it here in my design, so I'll do it here. Hang on for just a second. Let me pause the video while I bring that up. Okay, back again. So if we look at this design, over on the left-hand side I have a freeform version of the same lens, and on the right-hand side you have your original design for this right eye. And if we look at this, compare the two, if you go to the 3 o'clock radial, you notice now I have a really nice alignment in the landing zone between the blue and the pink dot. That back surface of the contact lens aligns very nicely with the green corneal line. And in fact, if you go to each radial, you'll see I maintain very close alignment in each meridian. So I think that type of design philosophy will probably get you a better chance of this lens hugging that cornea properly. Another thing you can try, if this lens still drops a little bit on the fit, sometimes I'll go down to this inferior quadrant, click over to 50% control, and just steepen up this lower half of the lens by clicking down in the blue, and sometimes that'll help this lens gently push off the lower part of the cornea, encouraging that lens to ride a little bit higher. But I think generally speaking, if you get this free-form design, you'll probably get a little bit nicer centration overall. Now, with that said, if you continue to have difficulty with this particular lens achieving fit and comfort, I have had some of these cases fit very nicely into a mini scleral lens. And what I'll do is if you haven't seen the little Wave training video, I'll include a link on the email here. But there's a very nice video that kind of walks you through how doing an 8-point step to develop a mini scleral lens. And I found that quite often, if there's a lot of lens awareness in some of these patients, you can achieve some very nice comfort and fit by going to that type of design. Well, anyways, it looks like you're well on the right path with this patient. I wish you well, and thank you for contacting Wave Support. Have a great day.